Hello everyone, you must have seen in my previous videos that whether I'm designing Twitter or I'm designing TinyURL service or I'm designing Uber, in non-functional requirements I'm discussing about the consistency requirement, whether the operations that will perform in that service, whether they will be strongly consistent or whether they will have an eventual consistency. Recently I also performed a mock system design interview about the system design of Instagram newsfeed. And I asked the candidate about the number of likes on a post, that how we will actually calculate it. And the candidate replied to me that we will use eventual consistency because it is okay to use eventual consistency there. But I think this is a wrong understanding that the candidate had. Usually if you have to decide whether you want to use a strong consistency or eventual consistency, you just don't decide to use strong or eventual based on, oh, it's okay to use eventual consistency here. That is why we will use eventual consistency. Ideally, we always want to have a strong consistency on all our write operations. But of course, sometimes it's not practically possible to achieve strong consistency. Also, there are other situations where we can achieve strong consistency, but achieving strong consistency results in a large latency or performance overhead. And in that case, we have to check three things, that what will be the effect on those three things if we switch away from strong consistency to eventual consistency. And those three things are: number one, the reliability of the service; number two, the functional correctness of the service; and number three, the user experience. So let's go through some examples. You must have seen my previous video on designing TinyURL service, which you can find the link here. In the design of TinyURL service, we discussed that let's suppose we have our service here, and then we have a user, and when the user invoke the create short URL API, and the API returns successful and returns a short URL to the user, then we assume at that time that this operation will always be strongly consistent. And why we need this to be strongly consistent? Because let's assume that this operation is not strongly consistent. Then it's totally possible that once the user gets a short URL and then it tries to get the big URL using the short URL, get big URL, if the first operation is not strongly consistent, then this call may fail and could return not found. And this will result in bad user experience, because once the first API returned, the assumption user had was that now the short URL to big URL mapping is created in the service. And so now what the user will do? The user will become confused and he will try to again call this API. This subsequently will result in affecting the reliability of the service and the functional correctness of the service. And that is why we discuss in the design of TinyURL service that the creation of a short URL, this operation has a strong consistency. And using eventual consistency will result in negatively affecting these three properties that we have. Now let's consider another example. We have discussed the design of our tweet service. You can find the video here. In that design, we didn't discuss about how we will actually calculate the number of likes on a tweet or a post. But this is I asked in a mock interview that you can actually find in my course, which is the design of Instagram newsfeed. So the design of Instagram newsfeed or the Facebook newsfeed is similar to the design of Twitter timeline service. So if you know the design of the Twitter timeline service, you can actually design Facebook newsfeed or Instagram newsfeed as well. So I asked the candidate in the mock interview that let's suppose we also have to calculate the number of likes. So how we will calculate the number of likes? And the candidate told me that we will be using eventual consistency here because it is okay to use eventual consistency. But then this is a wrong answer from the candidate. We don't use eventual consistency just because it's okay to use eventual consistency in some scenario. We always prefer strong consistency. But the only reason why we switch to eventual consistency in some scenario, because going with strong consistency is either not possible. So it's either not practically possible or have a very high cost and performance overhead. Let's suppose we have this Twitter service and we would like to add a feature to actually get the number of likes by other users on a tweet. So let's go to our data model. What the data model would look like. So we will have these two tables. Let's suppose we have a tweet table which has a tweet ID, which is a primary key, and we have a content of a tweet, and we have the likes count, which is a long integer. Similarly, we will also have tweet likes table, which has a primary key comprised of tweet ID and a user ID, and then of course we have a created time, which is a timestamp. And so whenever a user likes a tweet, we will actually insert a record in this table, and we will also increment this count. And whenever the user remove his like, we will actually go in this table and delete the entry from here, and we will also decrement this count. Now, if you must have seen my previous video on designing Twitter service, we will be sharding this table in order to scale our service, and there were different sharding approach that we discussed. Let's suppose one sharding approach is we are sharding the database based on the tweet ID. So now, if we consider these two tables, all the tweets that are in a partition, if we shard these two tables by the tweet ID, then we can safely assume that a tweet and all the likes for a tweet will be in the same partition. So now let's suppose if a user has to go and like a tweet, the tweet like operation or the API will actually come to the tweet service, and now the tweet service has to insert a record here in the tweet likes table for the user and a particular tweet, and it also has to increment the likes count in that for that tweet here in this tweet table. Now of course we cannot perform updates or inserts in two different tables atomically. We need to use transactions. So whatever data store is being used, it will provide us some sort of transaction support here, and so we will open a transaction. So we will begin our transaction. Inside that transaction, we will actually insert like record in tweet likes table, and we will also increment likes count in tweet table, and we will commit the transaction. By the way, if you are thinking that are there any NoSQL data stores which actually support transaction? Yes, there are. If you check Apache Cassandra or DynamoDB, for example, they also support a transaction construct, but those transactions are lightweight transactions. Usually data stores don't provide any such transactions which crosses partition boundaries, because locking multiple partitions under a transaction is a heavy process and it has huge performance impact. However, many NoSQL data stores provide some lightweight transaction where you can actually perform operations within a transaction as long as those operations are affecting a single partition. So in our partition scheme, we discussed that we will be partitioning our data store based on the hash of tweet ID. So a tweet and all its likes will be in the same partition. So actually we can perform this operation. But now there is an issue with this operation. Let's suppose if there are multiple users who try to like the tweet. Let's say 10 users try to like a particular tweet. What will happen? There will be 12 like API calls that get invoked that will go to the tweet service. So you can assume 10 different threads running on different hosts maybe. They will all acquire the transaction. They will insert a record here in this table for the tweet ID and the specified user. And inserting a record in this table has no issue. There's no conflict here. But then they will also increment the likes count in the tweet. And now this is an issue here, that let's suppose the likes count was initially 10. And now 10 different likes operation come in parallel. They all open the transaction. Inside the transaction they read the previous value, and they all read the previous value as 10. And then they all increment the value to 11, and then they all try to commit. But now out of those 10 transactions, one transaction will commit successfully, and the rest of the 9 will get commit conflict, and then they have to retry again. And now out of those 9, one will succeed, and then other 8 operations have to retry. Then out of those 8, one will succeed and other 7 will have to retry. And let's suppose now if the retry count is only 3, then it means after 3 retries most of the like operation will fail, and they will send the fail notification back to the user, and the user will see that he tried to like a post but the like operation failed, which will result in a bad user experience. Of course, we can configure the number of retries to some value, let's say 5 or 10, but we cannot arbitrarily increase the number of retries. We can also introduce some jitter within the retry thing, like some random delays, but still the main thing is that the user experience will be bad. There will be some like operations that will fail, resulting in bad user experience, and there will be some like operations that will take unusually high time, again resulting in bad user experience. So now it seems like we do want to have strong consistency while we are updating this likes count, but achieving this strong consistency results in this issue of bad user experience. So now we actually take a step back and we think, why even we want to have a strong consistency? Do we even need a strong consistency here in incrementing this likes count? What will happen? Let's suppose if the user is not able to see the exact value of the likes count. What if we actually eventually make the likes count consistent with whatever the exact value it has? Is it going to have any bad user experience? Is it going to affect the reliability of the service? Is it going to affect the functional correctness of the service? And when we will discuss these things, then we will see, oh, let's say if a tweet has 1000 likes, and if a user sees 1000 likes instead of 1001, it's not going to affect the reliability of the service. It is also not going to affect the functional correctness of the service. It is also not going to cause any bad user experience. So in that case, we will say, okay, achieving a strong consistency in this case has issues that we discussed. So we will actually not try to update the likes count in a consistent manner. So what will happen now? Whenever a user likes a tweet, we will only insert a record here, and then we will increment this like count asynchronously. Now there could be multiple ways to achieve it. One way is that every time a user likes a tweet, we actually insert the record here in this table, and we also insert a record in a queue, and then there is a worker agent which actually then processes the message in the queue and updates the likes count asynchronously. In that case, this likes count now is getting updated eventually, but having eventual consistency here does not affect the reliability or the functional correctness or the user experience of the service in a negative way. Let me know also in the comment below what are the other ways that you can think of in which we can actually update the likes count. Now we have another example, which is a design of Amazon Marketplace, for example, and we have an inventory table and we have an inventory count here. Now the question is that whether we can achieve eventual consistency here or not, because it's almost the same thing, where just like in the tweet scenario where the users were liking the tweet and then we were updating the likes count eventually in asynchronously in a background thread. Here the users may see a number of inventory and they will be buying the inventory, and as they are buying the inventory count will go down. But now the question for you guys is that can we use eventual consistency here or not? Let's suppose we say, okay, we will actually use the eventual consistency here. So in that case, it's totally possible that users see there's an inventory count of 1 and then he tried to buy the inventory, but actually the inventory count was 0 at that time. What will happen in that case? We will try to book an order and we might book an order, but the inventory is not there. In that case, it will actually cause a negative effect on the reliability of the service. It will also cause negative effect on the functional correctness of the service, and it will result in a bad user experience. So it seems like here we cannot avoid a strong consistency. I have a question here for you guys. How we will solve this problem now here? Let me know in the comments below. That we know clearly right now, if multiple users try to buy the inventory and every buy order results in decrementing the count, then of course if multiple users try to buy the inventory at the same time, we will actually try to decrement the count in a way which will actually cause commit conflict against multiple light operations that are coming to this table. But if we actually use eventual consistency model the way we use for the tweet likes count, this will result in again bad user experience, and it will have a negative effect on the reliability and the functional correctness of the service. So how we will actually solve this scenario? And it's a very common question. If someone asks you to design Amazon Marketplace, the interviewer will ask you about solving this issue as well. And it's a common thing. You will see it many times, not just tweet scenario here, but even other things as well. Like for example, if you are writing an IAM service, you have a group and you can have a maximum limit on the number of users in a group. Then it means every time you insert a user in a group, you are incrementing a group count. And you have the same problem there as well. How you will make sure that the number of users in a group does not exceed the limit, but at the same time incrementing the user count in a group table by multiple threads at the same time results in commit conflict. So how do you avoid such scenario? Let me know in the comment below. Now let's discuss the third scenario. In our previous video on design of Dropbox service, which you can find here, or if you go and check my course, we have a detailed chapter on the design of Dropbox service. We discussed about different non-functional requirements, and we decided that we will actually use eventual consistency in case of Dropbox service. And I go into more detail in the chapter there, that what does the strong consistency or what does an eventual consistency means in case of Dropbox service. So let's discuss this here now again. Suppose we have our Dropbox service here, and then we have multiple user devices. Let's say device 1, D1, we have device 2, D2, and we have device D3. They are connected to our Dropbox service. Okay, and now what happens is that user actually updates a file here in D1, and we would like those updates to get reflected in device D2 and D3. Now think about it. If we would like to reflect this update to these devices in a strongly consistent manner, then what we need to do? First of all, while the user is going to perform a write here, we have to log this file here in this device D1. We also need to log this file for both read and write in device D2 and D3 as well. And then when the user perform a write here, we have to actually first replicate that change to the device via Dropbox service. And once the change has been replicated to other devices, only then we can actually unlock the file for both read and write. Clearly, achieving this strongly consistent behavior is practically impossible, because we may not know whether a device, let's say D3, is online or not at the time when we are trying to update the file on the device D1. And that's why we decided, okay, we will actually use eventual consistency here. But now again we have to think about the other scenarios. If we decide to use eventual consistency, that what effect is going to have on the reliability, functional correctness, and the user experience of our Dropbox service. Now we discussed in the chapter that let's suppose if we allow the user to update a file while the device is offline, it has several issues. For example, the user can go and update the file here in D1, and it can also go and update the same file here in D3 as well. And now if those updates happen in the same chunk or the segment of the file, then when those updates go to Dropbox service, the service will detect that there is a conflict in that segment. And now how to resolve that conflict? It's a hard problem. And the only way right now the Dropbox service, what it could do is that it can actually keep both the segments and notify the user that, hey, you have this segment in the file which have some conflicts, and I don't know which version of the segment I should take, so let me know. That would be one way to resolve the conflict. But this is a possibility of a conflict that can happen because of the eventual consistency. But the question is that whether it's possible to avoid this eventual consistency in case of Dropbox service or not. And as I said, it all now boils down to the requirement. If the requirement is that you can actually update a file while the device is offline, then you cannot avoid this conflict. Either you have to change your requirements and you have to say that you can only update a file on a device while the device is online. But how you will actually enforce this behavior, it's again an issue. So you see, in an interview, you are not expected to solve everything, but what you are expected is to discuss different trade-offs. Like if you take this requirement versus this requirement, what are the effects of going with this requirement than this requirement? If you take this requirement, how are you going to design your system to achieve this requirement? Or if you take this requirement, how it's going to affect the design of your service if you want to go with this requirement. So in an interview, as an interviewer, I am actually looking at the candidate to discuss all these trade-offs between different design decisions. This becomes apparently very important if you are targeting senior or principal level software engineering positions like L5 or L6 plus. In my course, you will find all such trade-offs, like what are different types of partitioning approaches we can use. What if we go with this sharding approach, then the other sharding approach? What are the pros and cons? All those things I have discussed in greater detail in my course. In the end, let me know in the comment below what are the other examples where you would like to go with the strong consistency, but achieving a strong consistency is not either practically possible or have a very high cost and performance overhead. And that's why it's better to go with eventual consistency, because going with the eventual consistency is not going to negatively affect the reliability, functional correctness, and the user experience of the service for that scenario. Also, let me know in the comments if you like this video, and please do subscribe to my channel. There will be more videos coming in the future as well. Thank you and take care.